Bridge. This is week 2 and it is our first lesson, so this is 2.1. If you would like to have the paper that I typed up, or if you want to have that open in a separate tab, probably a good idea. I'm going to go over the first page with us together, and then most of the second page is going to be left for you to do for your assignment. I do have a bridge of the day. Uh-oh. Okay, take a guess. Okay, it is called the Tjorn Bridge. It is in Sweden. Cool bridge in Sweden. Let's move on to this first one. You are going to need an 8.5 by 11 sheet of paper or a scratch piece of paper, whatever's fine. It asks you to fold the paper in half, and then we're going to record how many sections we have after folding it in half. All right, so the instructions say to fold your 8.5 by 11 sheet of paper in half. So this is with 0 folds on the table. It says 0 folds. How many sections do I have? I just have one entire section. If I fold this thing in half this way, you're gonna get this. So this is after one fold. Now how many sections do I have? I've got 1 and 2, right? So after one fold, I have 2 sections. Now I'm going to make 2 folds. So I'm going to fold this in half twice. So I'm going to fold it once. I'm going to fold it twice. Okay, so this is after folding it in half twice. And if I open it back up to the original sheet of paper, how many sections do I have now? You've got 4. 1, 2, 3, 4. All right. Now fold it in half 3 times. So that's once, twice. Let's go 3 times now. All right, that's 3 folds. How many sections do we have? Uh-oh. Okay, you can count those up and you have 8. Continue doing this. The next one says 4 folds. So 1, 2, 3, fold it a 4th time. See how many sections you have. So we saw that after 0 folds, we had one entire section. We have not folded the paper so far, so we only have one section. Once we folded it in half once, we opened it back up, we had 2 parts. All right. We folded it in half twice, we had 4. We folded it in half 3 times, we had 8. Do you see a pattern here now? If you want to pause and continue on and fold in, see what you get. After 4 folds, you should get 16 sections. After 5 folds, you should get 32. And it kind of looks like I'm doubling every time, right? Because cutting it in half is just going to it's going to double everything. So from 1 to 2, I'm multiplying by 2. From 2 to 4, I'm multiplying by 2 again. From 4 to 8, multiply by 2, multiply by 2. So from 32 to get to the next one, after folding this in half 6 times, you should have, well, 32 times 2 is going to give you 64 sections. So that's how you fill out the table. And now I'm asking myself, can I write an exponential function that models this data right here? Well, again, we know that exponential functions are of the form y equals a times b to the power of x. You've heard this a billion times, where a is our initial value and b is our growth or decay factor. I'm just going to call it growth factor. Okay, so our initial value is whatever we're starting with. It's where x equals 0. So from the table, if I look, let's just kind of call this, I'm going to call number of folds x and number of sections y, just to assign some variables to this, our input and our output here. So if I try and find where x equals 0, well, when x equals 0, y equals 1 right here. So my initial value has to be 1 times, and then what's our growth factor? What am I growing by? What am I multiplying by every time? Well, we're multiplying by 2 every time, as we see in the table. So my b value has to be 2, and then to the power of x. So there I could write my exponential function as y equals 2 to the power of x. You can multiply it by this 1, but it's just multiplied by 1. It doesn't really matter. So there we had a table of values. We were able to find an exponential function that fits those points, y equals 2 to the power of x. My next question I give you these two graphs, and I say if you had to graph this table of values, if you had to plot all those points, or if you had to graph this exponential function that we just made, would your graph look like the red graph? Would your graph look kind of like this? Or would your graph look more like the green dotted graph? Well, if we look at the green, I know that this one, as x increases this way, as we go this way on our x-axis, I can see that my function is getting smaller, right? It's sloping down this way. This green one, I know, is a decay. It's exponential decay. However, if we look at the red, with the red, as our x increases, again, as we move this way, I see that my numbers are going up. So this has to represent an exponential growth function. And if I look at my table, my numbers are definitely getting bigger, and my growth value here is greater than 1. So what do you think? Is it going to be the red, or is it going to be the green function that you're going to put down here? All right, if you want to type it out, if you want to write it out, however you're doing this, that's totally fine. Okay. All right, now I am on part 2, and this is the assignment part. I'm going to get you started just so you know what we're talking about exactly. It says take another 8.5 by 11 sheet of paper. You can use the same one if you want. And we're going to be folding this in half again. But now, instead of the number of sections that we're looking at, we're going to be looking at the area of the smallest section. So after 0 folds, I have not folded this paper. What is the area of the smallest section? And we're just going to take this relative to the actual paper. So we're going to say that this is an area of 1, all right? So this thing has an entire area of 1. So after 0 folds, the area of my smallest section is 1. That would be filling in the first part of the table. I'm going to make 1 fold, all right? So I'm going to fold this in half once, and I'm going to... Okay, so now I have this. I folded this in half, and my smallest section, now it's not the entire page because I've put this in 2 sections. My smallest section is just this part right here, right? And this part is half of the entire whole. So now my smallest area is 1/2, right? Because there's 1/2 here, and then there's going to be 1/2 up here. So for 1 fold, my area of the smallest section is 1/2. So I'm going to fold it 2 more. I'm going to fold it twice now, or I'm going to make 2 folds. So now I'm going to fold it once. I'm going to fold it in half a second time. So that gives us 2 folds of the paper. And if I open this up again, all right, I'm going to look at the other side. Now I have 4 sections. So that means that there's 1/4 of the area is here, 1/4 of the area is here, 1/4 of the area is here, 1/4 of the area is here. So after 2 folds, the smallest, or the area of the smallest section is now 1/4. Okay? Now let's do 3 folds. So I'm going to fold this 1, 2, and I'm going to do it a 3rd time folding. Opening this back up again. I'm going to see how many sections I have. What's the smallest section? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. So this would be the smallest section after folding this 3 times. And this section makes up 1/8 of the entire paper. So after 3 folds, after folding this in half 3 times, the smallest area, or the smallest section, that area is worth 1/8 of the entire thing. All right. So we just saw how to do part 2. I'm going to show you how to start filling in the table, and then I'm going to ask you to do most of the rest of it. So we said after 0 folds, we had an area, we had a total unit area of 1. And of course, we're just kind of guessing, we're kind of going by units. We're not looking at area per square inch or whatever. I just want to make this easy on this. So after 0 folds, you have 1 full sheet of paper. I have 1 full sheet of paper, and I already have that typed out right now. After 1 fold, we saw that we sectioned it off into 2 halves. So one of the smaller sections would represent 1/2. So the area of my smallest section after 1 fold was 1/2. After 2 folds again, we saw that we cut it into fourths or 4 sections. So the area of the smallest section would be 1/4. Again, with 3, we had 1/8. And again, we're just cutting these all in half, right? So if I cut 1/8 in half, you're going to get 1/16. If I cut 1/16 in half, you're going to get 1/32. Does this kind of look very similar to what we did up here? 1, 2, 4, 8, 16, 32. Can you guess what the next one would be? So after folding in half 6 times, you're going to get 64 sections, and one of those would represent like the smallest area. You would have 1/64 of the entire page. So if we're cutting these in half every time, you could think about it as dividing by 2, dividing by 2. And if we're always doing multiplication with our exponential functions, because exponentials are repeated multiplication, dividing by 2 is the same thing as multiplying by 1/2. So really what I'm doing here is I'm multiplying by 1/2. I'm multiplying by 1/2. Multiply by 1/2, by a half, by a half, by a half. All right? I'm going to leave it there. Hopefully you will be able to figure out what your initial value is, because we need to have, for this exponential function down here, we need to have some a value times a b value, okay, b to the power of x. See if you can find your initial value from the table here. See if you can find your growth, or in this case, possibly a decay factor, all right? Write your exponential functions. So I'm going to say that this is my x and my y. So y equals, again, tell me what that is. And then number 6, we're looking at the same graphs again. We've got this red, which we said indicated growth. We have this green, which indicates a decay exponential function. So tell me, after you have this exponential function and looking at the table, if you plotted those points, if you graphed that function, would you have a growth or decay function? Would you be seeing a red line, or would you be seeing a green line? And then the bottom question says, what might be different if you tried to do this, instead of with paper, if you try to do it with tissue paper or wax paper? Because that would be a thinner material. What do you think you could do? I'm also curious, what's the max? Like, I could only fold it about six times. That's why I put 6 in the table. Can anyone fold it 7 or 8 times? Are you that strong? I don't know. Please submit this assignment so I can see what you did. If you want to do it in Google Docs, you totally can. And if you want to upload a picture of your pieces of paper that have been folded, please do that. And I forgot to say, thank you so much for all of your work last week. I think it was there were some problems and we figured it out together, but I think this is going to start moving a lot smoother. Thank you for your work. Thank you so, so much. Keep those questions coming. Do your best. Adios. Go team.